In this video, we're going to discuss sets and maps. Sets and maps, from a conceptual view, let's start with a set. A set is a well-defined collection of distinct objects. You guys all should be familiar with this from math. A set itself is also considered an object in its own right. You can have sets of sets. So, for example, 2, 4, and 6 are distinct, but when they're considered separately, but when considered collectively, they form a single set of size 3, written 2, 4, 6 with squiggles. Sets are fundamental in math. In computer science, a set is an ADT that stores specific values with no implied ordering and no repeated values. Let me repeat those 2 points. There's no implied ordering. You cannot guarantee the order of something in a set, implementation point of view. And it cannot handle repeated values unless it's a different type of set, which we'll come back to. It's a computer implementation of the mathematical concept of a finite set. Unlike most other collection types, you don't really focus on retrieving elements. You simply typically test for membership. So why do we want to do that? Well, lists and vectors are inefficient when it comes to searching. May you ask why? Well, it's because in a worst case, you have to look through every single item in the list or the vector to find what you're looking for. So it can have a worst case of O of n. Okay. We have already discussed sequential containers, vectors, decks, lists, arrays, etc. The programmer controls the order in which elements are stored and accessed. The order doesn't depend on the value, and the order depends on the position at which the elements are put in the container. Now we're going to look at what are called associative containers in STL. A container is composed of a key-value pair, where the key only appears one time in the container. It's unique within the container. The key is used to find the value within the container. So basically, it's like a dictionary. You have a word and you get the definition. Okay. The main difference between an associative container and a sequential container is the use of a key to store and retrieve elements. Okay. For a set, the key and the value are the same thing. Okay. Meaning, you only have one value. Like if you put 3 in a set, 3 will be both the key and the value. For example, we can hold a set of words we want to ignore during some kind of text processing. And the names of individuals who've written bad checks, or anytime we want to test efficiently whether a key is present. Now, a map is a little different. In a map, the key is the index to the value. A phone book. In a phone book, for example, the phone number would be a key, or the name would be a key. Depends which way you want to look at it. In a dictionary, a word is a key to the definition, which is your value. Anytime we want an efficient way to look up a value, defined by a key, but with different values. In STL, you can have ordered collections, which are ordered by a key pair. Elements ordered by a key. A map is an associative array, and it holds a key-value pair. A set is a container in which the key is the value. Similarly, a multi-map is a map in which a key can appear multiple times, and a multiset is a set in which a key can appear multiple times. That's an ordered collection. You can also have unordered collections not ordered by a key, and similarly, you'll have unordered maps where the maps are organized by a hash function. We'll talk about that later. An unordered set where the set is organized by a hash function. An unordered multi-map, which is a hash map, keys can appear multiple times, and an unordered multi-set, hash set, keys can appear multiple times. A hash is a function that maps maps a domain onto a specific range. So, for example, you could have a string map onto an index into an array. In the next video, I will show you some examples of how to use these structures.